To dive into this topic, imagine the following scenario. Olivia, she's the Chief Information Security Officer of a large international bank. Her job is it to keep her customers' data safe. Over time, the bank is transforming into a technology company, as we know from daily experience. Her task is to keep their customer data secure and in compliance with industry regulations, no matter what the technology the company adopts. Currently, all her data exists in on-premises data center. Historically, this has given us some pretty key advantages when it comes to data protection, because all lives in hardware in buildings she owns and manages. She can be absolutely certain about how this data is handled. Ultimately, as a CISO, she takes responsibility not only for her customers' data, but also the processes around how data is handled. To keep the data even more secure, she can use encryption wherever appropriate. With encryption in place, the impact in case that data gets lost will be dramatically reduced. Without the keys to this data, they are of no use to anybody. But now, the technology owners of her business are pushing to adopt to the public cloud. This introduces a new, unique challenge to her. She has to secure customers' data without having total control over how customers' data is handled. She has now to conform to what public cloud providers call a shared responsibility model. Well, a shared responsibility model looks something like this. You probably have heard about it. What the business really cares about is the top layer of this diagram. That's the business logic. This is how we address the markets, how a company differentiates itself from the competition, and most importantly, how a company generates revenue. Everything below that, in the gray area, is just an enabler. The capabilities and efficiencies within these enablers determine how agile we are in the market. I think we all agree that we don't want to become experts in each area of this diagram just to build good applications. So think about the following. Our organization doesn't need to become the best in the world, for example, in server hardware, to become a market leader in banking. If you are able to consume the underlying resources as commodities, that let us divert far more resources in building great software. Then we can let someone who has become expert in managing servers take care of that for us. This is really the origin story of the public cloud. Amazon, for example, owns a platform where we have access to on-demand server hardware. Naturally, as these cloud offerings have matured, they began to offer more and more services. Now, you don't need to know how to build a globally always available network just to deliver a great banking experience. You can leverage companies who have already proven to be good at that, and you can consume it from that as a service. As a bank, you don't want to have to pay the bill for a team of operating system experts just to run your application. Your resources are far better utilized by focusing on building great user experience for your customers. Then we get there where we are today, where almost every part of the IT infrastructure is available to us as a service. This allows us to divert far more of our resources than previously possible to the part of our business that really makes the difference to our business. The efficiency and quality advantages of a shared responsible model are the reason why the adoption rate of public cloud is increasing year by year. But now there is one person that this doesn't help, and that's Olivia, our CISO. Olivia is now faced with the problem how to keep her customers' data secure, even though she has no longer control over where it is stored. So the question pops up, how do we get organization like Olivia's in a position to exert the same level of control around her customer data, especially for an industry that requires a highly regulated environment? The solution we have to come up with is some mechanism where Olivia can generate the keys in her own environment and then securely distribute copies of the keys out to the public cloud. Fortunately, the public cloud providers have already come up with a solution to this. This is called the bring your own key method. Depending on what cloud provider, you might call this method slightly different. In general terms, there are 4 things we can achieve by using bring your own key. First, your industry might require you to be able to deliver encryption keys with a particular level of randomness, or let's say entropy. This randomness might have to come from a hardware device. Second, you might have to contain with the idea that one day you might have to remove yourself completely from that cloud. And if you do that, you must be able to take all encryption keys with you. Third, you might have to build in your own ability in disaster recovery processes that is supplement to the cloud provider processes. To do so, you have to have your keys outside the cloud provider's infrastructure. And fourth, in certain cases, you might have the technical use case that require some part of your encryption keys to be available both in the public cloud or in your on-prem data center. So, where does Cloud HSM or on-prem Primus HSM fit into this scenario? Cloud HSM or on-prem Primus HSM give you a centralized place where you can operate and store your key material. As I'm responsible for generating my keys myself, I can use the methods already approved by my industry. Cloud HSM or Primus HSM can be used directly to deliver bring your own keys to the cloud provider. All Cryptographic functions are available over APIs. And if required, you can pass randomness for your evaluation by statistical tests. In some cases, it might be beneficial also to use and integrate the root key store or the key store provided by Cloud HSM or Primus HSM through key management systems like HashiCorp Vault, like BYOK and others. It eases the way of interworking with the keys and provides automation which simplify the key management, lifecycle, rotation, revocation issues. In both cases, the generation of the keys remain under your control. Now let's have a look at the workflow to import directly BYOKs to Azure Key Vault. We have based our example on Azure because of the high adoption rate, as we also saw in the polls. And especially in regulated industries, but the workflow applies similarly to other cloud providers.